The derivation sheet serves as the conceptual anchor for the project, translating abstract geometric theory into a functional interactive experience. It organizes this transition through two primary visual frameworks: a state diagram that tracks the evolution of the geometric shapes and a sequence diagram that outlines the logic of the digital engine. The state diagram. From stability to transformation. The state diagram illustrates the journey from the rigid symmetry of a cube to the fluid proportions of a rectangular prism. Phase 1. The invariant cube. The narrative begins with a study of the perfect cube. This state demonstrates a unique geometric truth. As long as the shape remains a cube, the angle between its diagonals never changes, regardless of how large or small the cube becomes. Phase 2. The symmetry break. The diagram then tracks the transition into the prism example. By allowing the side lengths to vary independently, the fixed nature of the cube is discarded, and the internal angle becomes dependent on the specific ratios of the shape's dimensions. Phase 3. Diagonal dynamics. The final state explored is the animation of geometric extremes. It shows how the diagonals respond to dramatic shifts in shape, closing together as the object becomes a tall, thin pillar or spreading apart as it flattens into a wide plate. The sequence diagram. The mechanics of interaction. While the state diagram defines the what, the sequence diagram explains the how by detailing the step-by-step communication between the user and the software. Input and trigger. The cycle starts when a user enters a new dimension and initiates an update. Scene preparation. To ensure a clean visualization, the system's first action is to clear any previous objects from the three-dimensional environment. The processing engine. The core of the sequence involves the math engine, which calculates the paths of the diagonals based on the new dimensions. Even when the size changes, the engine confirms that the ratio governing the angle in a cube remains perfectly consistent. Visual feedback. Finally, the renderer draws the new vectors and updates the information panel. This allows the user to see the physical change in the cube size while noting that the calculated angle remains approximately 70 degrees. For the more complex prism visualizations, this sequence evolves into a continuous loop. In this mode, the system automatically oscillates the width of the shape, forcing the engine to recalculate the angle in real time. This creates a live update where the diagonal arrows and data labels move in sync to show the angle opening and closing as the prism stretches and squashes.